I just wanted to look at some best practice in dealing with some data, especially when you get somebody else's data. So this is actually the sets of heights that I asked to be typed in one of my tutorials, but it doesn't matter where the data set comes from. And the first thing I should point out is it's a good idea, let's go back to that, to name your files and give them a date. Now when you're doing the date, what you want to do is have the year, then the month, and then the day. This means that when you list your files, they will be in date order in a Windows system. Because if you put them with the day first, then the month, and then the year, they won't come out in date order, because the 19th will come before the 2nd, because that's the way Windows organises its files. Because it starts with 1, that comes before 2. So 19 will come before 2, which is not very useful. 29 will come before 3, and so on. So I've named it in this way, which is actually a standard created by a standard organisation. So year, month, day. Now I've opened this file. I've got 3 groups labelled 1, 2 and 3. I've got sets of heights, and these are primary school children. So the question that's asked in the assessment that goes with this might say, for example, what is the average height from the students that go to the Sharia school? And you're sitting there going, right, but there is no Sharia school. It's not there. I've got group 1, 2 and 3. What's happening? So the first thing you should always do with your data is look in variable view. Now you're looking here because you want to know if there are any missing values, and you're also looking here because it tells you what the values are defined as. So here you can see that 1 is Sharia, 2 is Wycliffe, 3 is Gilmorton. Now I didn't actually need to do that to see if there's any specific labels. So you can see that the grouping variable is a nominal variable, even though it's 1, 2, 3. So if I go to view and value labels, now I can see Sharia, Wycliffe, Gilmorton. So it's always important to look at what the value labels are. Now, I've been asked to work out the average height for Sharia, let's say. So how do I do that? So if I go to Analyze, Descriptive Statistics, Explore, I pop in height, and I just want to work out the statistics. So I just want the mean height, so I don't need to do anything else, and I press OK. That gives me the mean height for the entire set of data, but I don't want that. I want a subset. So what I've seen is some people just cut and paste the subsets, but that's not how you really want to do it in SPSS. And you don't want to do it because you ideally want a table which contains all of them together. I'll tell you why as soon as we get one. So that's wrong. What should you have done? Go to Descriptive Statistics, Explore. So the group, the name of the school, is an example of what we call a factor. A factor is something that splits your dataset into subgroups. So you put the school as your grouping variable into the factor list and press OK. Now, instead of getting that single table which contains a summary of all of the height, you get summaries for each of the separate factors. So the mean for Sharia is 107, the mean for Wycliffe is 115, the mean for Gilmorton is 110. But better than that, it also gives you the confidence intervals. So this one goes from 100 to 113, this one from 110 to 120, this from 105 to 116. Now, the amount of overlap you get between these confidence intervals gives you some kind of estimate as to whether they're the same or not. If they completely overlap, like the ones from Sharia and Gilmorton, then there's no difference in height. If there's only a partial overlap and it's very tenuous at the end, then you begin to believe, so the highest value of here is 130, the lowest value of here is 110. This is suggestive that Wycliffe has got taller students than Sharia. It's not conclusive, but it's suggestive. and that's an important piece of evidence for suggesting there's differences in heights between the different schools.